Chapter 3 focuses a lot on dealing with angles, specifically angle pairs. So angles often work together to give us things that we can do with them. Some of these angle pairs we've actually seen already, we just haven't necessarily talked about them. Like the first one, adjacent angles. Adjacent angles are two angles that are next to one another that share a middle ray and a vertex. Adjacent angles are ones that look like this. They're the two angles that are just kind of sitting right next to one another. We dealt with this type of angle all the way back in chapter 1. Because adjacent angles are when we use that angle addition postulate. We say two angles right next to one another sharing that middle ray can add up together to make the big angle. Two that we haven't necessarily talked about, but you may have seen pictures of already, are a linear pair, which is two adjacent angles that form a straight angle. So they look something like straight angle or a line with a ray coming off of it. And the last one we're talking about today is known as vertical angles. Now, vertical angles end up looking like two lines crossing, and it's the angles that are across from one another. So in the way that I drew it, angle 1 and angle 2 are vertical angles. Or you could have looked at angle 3 and angle 4. Now we identify these angle pairs because what type of angle pair that they are will tell us what we can do with them mathematically. So, being able to identify which pair of angles we're dealing with is going to help us as we move forward. So, that's going to be the first thing that you see today. And in fact, that's going to be the first thing that you see on a lot of days. On a lot of days, the first thing that we are going to do is just recognize our angle pairs. So, in this one, it wants to know if the angles marked with the A and the B are a linear pair, are they vertical angles, are they just a basic adjacent angle, or are they none of them? So, I've got angle A, and I've got angle B. Are they right next to one another? Are they sharing a middle line? Yes. Do they make a straight angle or a straight line? If we just focus on them, essentially this and this are extra information because those are not parts of the angles. Do they form a straight line? No. Okay, next to one another sharing a middle ray, not making a straight line is adjacent angles. So that's our first one. Problem 2. Here's angle A. Here's angle B. Are they right next to one another sharing a middle ray again? Yes. Are they forming a straight line when they do it? No, which makes them what kind of angle pair? Adjacent again. Now, before I move on to the next ones, I just want to point out something about these two. They're similar. They should be. They're both adjacent angles. They're both next to one another. But this one has something, the first one has something that the second one doesn't. Do you notice a piece of information that this one tells you that this one doesn't in its picture? Where the lines connect. Yes. Not quite what I was going for. Ooh, I heard someone say right angle. Do we see this little right angle here? Those two angles, and it's really, really tiny, but those two angles form a right angle. What's a right angle? It's a 90-degree angle. If I have two angles that sum to 90 degrees, we actually talked about this definition a little bit last chapter, but we only put it on our orange sheet. Do you remember what two angles that add up to 90 are called? Starts with a C. They're complementary angles. Okay. We'll come back to the rest of those blanks. We're going to go back to this. Question 3. Angle A is this one. Angle B is this one. Are they right next to one another, sharing that middle line? No, if you look at where I outlined, it didn't overlap, except for at this tiny little spot in the middle. Now that means they're not adjacent. And if they're not adjacent, they cannot be a linear pair. Which means the next thing we're looking at is vertical. Do they form an X? Are they across from one another on the X? Yes, that is vertical angles. Now, vertical angles is going to be one that we write out enough that there is a technical shortened version. It's called VA for vertical angles. Adjacent doesn't have a technical shortening, hence the reason you just see me write ADJ and then the angle symbol. Okay, question 4. Angle A is right here. Angle B is right here. Are they sharing a middle line? Yeah. Yes. They are next to one another sharing a middle line. Do they form a straight angle when they're together? Do they form a straight line? Yes, these two rays make a straight line. That is what makes a linear pair. Again, we use it enough, it tends to get shortened down, LP. Those are the questions that I go through with myself when I'm looking at these problems. I ask, are they adjacent? And if they're adjacent, do they make a straight line? If they're not adjacent, do they make an X? And are they across from one another on it? So, I'm going to wait on cards for a little bit longer. Question 5, angle A is right there. Angle B is right here. Are they adjacent? Do they share a middle line? Yes, it overlapped right here. Do they make a straight line? Yes, that makes them a linear pair. If you'd prefer just to write LP, I'm good with that. Gesundheit. Okay. Question 6. There's one angle. There's one angle. Are they adjacent? In other words, do they share that middle line? Yes. Do they make a straight line? Nope. They're making a right angle. If they do not make a straight line, that means they are simply adjacent. That's the only thing we know about them, is that they are adjacent. Did you notice that they formed a right angle? Did you see the little right angle symbol? What's that mean about those two angles?
90 degrees.
They make 90 degrees. And the word for that, two angles that make 90 degrees together, is? Technically, they are complementary. Did you have to tell me that? No. Okay, we got two more. And then we're going to move on and do some actual math with it. There is angle A. Here is angle B. Are they adjacent? Do they share that middle line? Yes. Do they make a straight line? When I say they make that straight line, I mean the two rays that are not the one they share. So I'm looking at this. Is this a straight line? No. There is a straight line here, but that's extra information. So they do not form a straight line, and if they don't form a straight line, but they are next to one another, they are adjacent angles. Okay, we got one last one on this page with a couple of definitions. This angle and this angle. Are they next to one another? Sharing that middle ray. When we say share that middle ray, it needs to be overlapping. When I drew my kind of bluish and my reddish, did I overlap anywhere but at this dot? No. This one went here, this one went here. These ones are not adjacent. Adjacent requires that overlap in the middle. And if they're not adjacent, can they be a linear pair? No. Are they vertical angles? Do they make a perfect X? Emphasis on perfect X. No. Well, this makes one straight line. This one cuts off. This one cuts off. These are extra information. It kind of forms a K. So this is not adjacent, which makes it not a linear pair, which makes it, and since it's not an X, it's not vertical angles. This is that situation where they have no relationship. It's none of the above. Now, as you get further and further into this chapter, recognizing these angle pairs becomes kind of second nature for most people, just because we do it so often. But you will always have your postulate sheet that has the pictures on it that can help you out. Now, the postulate sheet that has the pictures, though, is actually trying to tell us other characteristics about these angle pairs, such as talking about this piece. If two angles have a sum of 180 degrees, do you remember what that term is? That's the one that starts with that S that we talked about in chapter 2. They make a straight angle together. It's not symmetric. That says things can switch around. It means they're supplementary. We had a lot of S words last chapter. They're supplementary angles. And some of our angle pairs are always going to be supplementary. Now, the last thing's on here that talks about two lines that intersect to form a right angle. is perpendicular. Perpendicular comes up a little bit in this chapter, doesn't come up a whole lot. Perpendicular being this symbol. Now I've got this picture off to the side for this specific reason. In this picture, if I need two lines that intersect to form a right angle and I want to find perpendicular lines, do you see any right angles in this picture? There's a little box here, there's a little box here, and there's a little box here. So, if I zoom way in on this picture because it's kind of tiny. This little box here, which two lines is it connecting? Or line segments if you prefer. This here. DC. And DA. So, DC, which is technically a line, is perpendicular to the segment DA. Are there other things perpendicular in this picture that you can see? No? Find the other right angle. There's one right here. AB is perpendicular to the part that makes up the other half of that right angle is this, DA. There's also this one here. This part, say J, is perpendicular to this part, which is HG. So being able to recognize from a picture what is perpendicular is something that you'll see a little bit of. That's why it's just such a tiny little piece on here. It's just kind of random in this section. It's not going to be our big thing. Mainly, we're getting back to those linear pairs and those vertical angles. Because we've dealt with adjacent. Adjacent angles, you could do the angle addition postulate on. Part plus part equals the whole thing. Today, more than anything, you're going to see the linear pair postulate and that vertical angle congruence theorem. So these are things that will pop up in proofs. We're not doing proofs today, but we do need to know these things. If they pop up in a proof, they are LP post, and VA theorem is generally shortened THM. So, linear pair postulate says if two angles are a linear pair, then they are supplementary. So if you see the picture, if you see this, then you could say the angles, which in this case are just labeled angle 1 and angle 2. We could say that they are supplementary. Vertical angle theorem says vertical angles are congruent. If you see vertical angles, so if we see this picture, where this is 1 and this is 2 and this is 3 and this is 4, then what does congruent mean again? What does congruent mean? The same, having the same measure. So if we see this picture, we could say the measure of angle 1 is equal to the measure of angle 2, or we could have said the measure of angle 3 is equal to the measure of angle 4. Because generally, when you come across one pair of vertical angles, you're generally coming across 2. The majority of what you're going to see today is not going to be just about identifying the angle pair, though that is important. It's going to be actually solving once you know it's a certain type of angle. So, I've got this one here. Cash. First name I've called. This picture right here. Are these a linear pair, vertical angles, or adjacent? Cash, you can't just straight up ignore me.
I don't know. Obviously, I've been sleeping the whole damn class period. You think I know how to do this shit?
Watch your language.
Oh, man, but like, obviously, I don't know what this is.
Okay, that's why I want your head up, please. I will come back to you on another question. Gabe. These are adjacent. Now with adjacent angles, we did not get a specific postulate or theorem that dealt with them from this chapter because we dealt with it back in chapter 1. It says the angles can add up. The two small angles add together to make the big angle. Measure, angle. Here's one of my small angles. Dylan, what is the name of that first small angle? Oh, I'm not looking for complementary. I'm just looking for the three-letter name. DCS, or I'm going to do SCD because that's what the thing has, but you're not wrong. DCS is correct. Plus, Callie, what is the name of the other little one? BCS. Equals. The big one, Jace. What is the biggest angle's name in this picture? DCB, or I'm going to write it as BCD because that's the way that it has it. That's what adjacent angles allows us to do. Part plus part equals the whole thing. Now in a proof, we would write this out. In a solving problem, I don't actually need you to write this out, but I wanted it written down here at least once. We'd replace them with what they're equal to. If this was a proof, what would be replacing these called? Substitution. And then we would solve because it says name the relationship and then solve for the variable. The variable in this case being x. In this case, x would be -7. I'm just quickly going through that math for you on this one. So identify the angle pair and do the math with it that it requires. Adjacent angles require part plus part equals whole. Okay, problem 2. Faith, what kind of angle pair would you say these two are? They are vertical angles. And according to our vertical angle theorem, vertical angles are congruent. In other words, they are the same or equal. So I could say that 90 is equal to my 5x minus 20. Technically, in a proof, I would do their names first. I don't have their names available to me. What do you think I do from here? Solve. Again, sake of time, you would get x is 22. Okay, problem 3. got this angle and I got this angle. Colin, what kind of angle pair would you say these two are? Okay. I'll come back to you on one. John, Jonathan, do you have a guess on what these two angles are called?
Linear pair.
They are a linear pair. According to above, if they are a linear pair, they are supplementary, meaning they add up to not 90. That's complementary. Supplementary adds up to 180 because they make a straight angle. X would be 27. Okay. Question 4. I got this angle and this angle. Tristan, what kind of angle pair do you think those two are? There is. It is vertical angles. Because if I look at this angle and this angle together, they kind of make this X. There's extra information here which throws things off, but they themselves are still making an X. Jackson, if they're vertical angles, what is true about these two angles? What's it say above in the vertical angle congruence theorem? Says they're congruent. What's congruent mean? What's between the two angles? They're equal. 44 equals 5x plus 4. You would get that x is 8. We got 2 more left. Joy, what kind of angle pair would you say these two are? They are a linear pair. This is extra information again. Kenna, if they are a linear pair, what do we know about them?
They're supplementary.
They are supplementary. Mari, what does supplementary mean again?
Maybe I forgot.
It's on the previous page. They add up to 180. So 40 plus the 7x plus 21 equals 180. X would be 17. Okay, we got one final one. Ella, what kind of angle pair do you think these two are? They are just plain adjacent. Now adjacent means I do the angle addition postulate. Part plus part equals whole. I need the two little angles and the big angle. Do I have the two little angles? Yes. But what's the big angle? The big angle being this one. If this one's a right angle, that makes this a right angle, 90. X would be 7. So that is what you are doing today, is you're identifying angle pairing and solving. Vertical angles are congruent. Linear pairs are supplementary, meaning they add up to 180. And adjacent angles add up to whatever it says they add up to. Okay, I know that it is a Monday and that we are a little bit sleepy. Many of you are a little bit sleepy.
A little bit.
Or very sleepy, whatever it might be, but I need all of you clocking back in because this is a short chapter. When is the test for this chapter? Next Friday. What do we have coming up on this Friday?
Quiz.
Quiz.